Okay, now for our third video, this is what we're going to be doing next. Now notice we went from 8.5, the end of chapter 8. Law of cosines is something that I think we can do without. Possibly we'll get back and revisit it and apply it to something we're doing later. Chapter 9, constructions, transformations. Always like doing that as our last topic of the year. So it's natural that we go into chapter 10 and we deal with some, probably some things you've heard before. And it's chapter 10. We're dealing with areas. And 10-1, our first section, deals with areas of parallelograms and triangles. Now, I'm going to write down two rules here. The area of a parallelogram, find the area of a parallelogram, it's base times height. To find the area of a triangle, it's half base times height. So there's your rules, and we're going to apply it, and we'll show what we mean, what we're talking about with regard to base and height. Very important to know what we're talking about there, base and height. Some folks might say length times width. That's a matter of perspective. The text and most textbooks at this level will say the area of a parallelogram is base times height. So if you want to take note of that, go ahead. I'm going to make a little space for me here. Areas of parallelograms and triangles. The area of a rectangle, right, if we saw a rectangle here, and I said this side length here is 8, and that side length there is 5, which would make this an 8 and make that a 5. I have a hunch most of us would know the area because you would do the base times the height. And some folks would say, well, if the triangle were standing up, it would be 5 times 8. If it's this way, it'd be 8 times 5. But either way, the area here is 40. Now again, depends on the unit of measure. If it's meters, area is square meters, right? Square units. Talked a little bit about area earlier in the year, how it's two-dimensional. It's not just a linear measure. It's two-dimensional. It's flat space. Okay, so the area of that rectangle is 40. Now, a rectangle is a type of parallelogram, so base times height. So if I were to, let's say, do something like that, and say this is a parallelogram, and that's an 8, an 8, and a 5, and a 5. Essentially taking this triangle and kind of pushing it over, right? Kind of pushing the top and forcing it to tilt a little to the right. And I guess you could say start to collapse. And just to draw an extreme version of that, you know, you've got an 8 and a 5 down here, right? Parallelogram. And you can see what's going to happen to the area inside, bound by that rectangle, that space inside, that flat surface area. What's going to happen as the parallelogram begins to collapse? What happens to the area inside? It becomes less. There's less area in there when that starts to happen. So that brings us to this idea. The area of that rectangle is 8 times 5 because the base is 8 and the height is 5. In this problem, in this parallelogram, if you don't see a right angle, and the right angle is crucial to telling you something about height. So if you were told this dotted line from here to here is perpendicular to these two sides, and that this is 4, what would be the area of this parallelogram? It's our inclination to say 8 times 5. But a height and a base they go together. Peanut butter and jelly, chocolate, chip, and cookie, right? Panini and bacon and cheese. Okay, they go together, the base and the height. okay? And what's going to tell you about a height and a base is a perpendicular segment. So this perpendicular segment here would act as the height, okay, to the base of 8. So what would be the area of this parallelogram? 32. And again, 32 square inches, whatever our unit of measure is going to be. Why not 40? Because this acts as the height. The height of the parallelogram is, right? What's starting to happen to the height? It's starting to fall. The parallelogram's falling, so the height is decreasing. So in this example, it's 8 times 4. You would not be able to figure out an area of a parallelogram unless you knew the height, right? You would need, the key to figuring out the height is the perpendicular segment here. If in our example way down here, if this distance, right, between these two sides, these two 8s, if that distance is 3, what's the area of this parallelogram? The area of this parallelogram would be 24, right? Again, you're looking for a perpendicular segment. Why don't we see this here? Because in a rectangle, the side is the height, because the two sides are perpendicular, right? So that's how we determine the area of a parallelogram. We're going to have a few problems with regard to area of parallelogram. Now, as far as the triangle is concerned, I wrote down the rule for that, but you can see what would happen here in a parallelogram if you had in a case like this. This was an 8, and that was a 5, and we did this and said that distance there is 4. We said the area of the parallelogram is 32, right? Area of parallelogram, 8 times 4, 32. When you draw a diagonal across a parallelogram, essentially what do you do to the parallelogram? You split the area in half, right? So the area of this triangle is 16, the area of that triangle would be 16. So while the area of a parallelogram is base times height, the area of the triangle would not be base times height, it would be half the base times the height. Because triangles are essentially half of any parallelogram, right? You could take any parallelogram and cut it in half. Give you a couple of examples, what you could possibly run into. You could have a triangle, right? Let's say you're told this is a 10 here, that side there. That wouldn't give you enough information to be able to figure out the area. That doesn't give you enough information. We have either you're going to use this as your base, and this would be your height, or you're going to use this as your base, and this would be your height. So let's, for argument's sake, say that this distance from there to there is 7. That distance there is 7. Okay. So what's the area of this triangle? The area of the triangle is half the base times the height. And arithmetic tells you you can do this number of ways. Some folks just do half of 10 is 5. 5 times 7 is 35. Some folks do 7 times 10 is 70, and you do half of 70, and that's also 35, right? That's the way multiplication works. So the area, again, when you're moving between parallelogram and triangle, a lot of folks look at that and go 70. I hope not too many people say 90, but some folks might say 70, but it's not, because the triangle is half the base times the height. Just want to go again, check on my video and not go too long on that. Okay, seems to be okay. Just want to make sure it wasn't too foggy. Right triangle. Here's our right triangle. Okay, 6, 8, 10. What's the area of that triangle right there? Half the base times the height. Now, what are you going to use as the base, and what are you going to use as the height? Well, when you're looking for base and height, I'm going to continue to emphasize that box, that right angle is going to be the key. Now, whether you use this as the base and that is the height, or you imagine the triangle flipped over and that's the base and that's the height, it's not going to matter. Because what's the area of this triangle? Half base times height. Area of this triangle, 24. Right? Half base times height. Okay, that's a right triangle. Remember, the two legs act as a base and a height. And one of the more unusual ones, the obtuse triangle, we'll say. Okay, the obtuse triangle, we'll say that's a 12, and this side length is 13. But what's the problem when you're asked to find the area of that triangle? Well, the problem's going to come in where you don't see a box, do you? You don't see a right angle. So we don't have a height, nor a base for that matter, in this problem. But in an obtuse triangle, remember altitude and height? It's determined by a perpendicular line perpendicular to the side length extended. So I'm going to come up with a number here. I'm going to say that's 12. So while this side length is 13, but there's no right angle there, okay, the distance from here straight down to this side extended is 12. So this becomes your height for this triangle. It's the obtuse triangle is always the weird one, right? So you're going to do half base times height. Now, we're going to use that 12 as the height. When we're dealing with the base, you're dealing with the side length. So 12. What's the area of this triangle? Half base times height, 72. Now they're going to try to throw one at you here. Maybe they're going to say, well, that distance there is 5. So what's the area of this triangle here? That doesn't throw you off one bit. You see a perpendicular segment going to this side extended. So that gives you the height. And you always go back to the side length that's across from that vertex. And that side length is 12. It's not 17. Okay? Half base times height. All right? So I think that gives you enough to go on for today. This is 10-1. 10-1. And I'm going to give you, I'm not calling them homeworks again per se because everything is homework now. We'll give you the assignment that you have to turn in the next day. We're going to call it assignment, and tomorrow's, or today I should say, is March 30th, so it's going to be assignment 3:30. You're going to do it, and you're going to turn it in by class tomorrow because we're going to have our answer key set up, and you can review it. I'm going to be looking to give you 5 points participation on that, making an earnest attempt. Some people skimping out, just throwing some numbers on the paper. Remember, we're looking for work. We're also looking for work on these. So please, a little bit of work. Okay? Take care.